myself Kamna Singh, and I am going to represent the page replacement algorithm. Today we are going to find out the computer architecture topic, and there is a page replacement algorithm. Fine. So in a page replacement algorithm, what is the need of page replacement algorithm? First of all, we have to understand what is the memory. Memory is the part where all the data and information has been stored. And if the particular memory having a larger size, that is fine. All the data and information are stored here. And you know that all the information and data are stored in the blocks. If it is the main memory I am saying, then these particular values are called as a blocks, and these blocks are the fixed size of blocks. Fixed size of blocks means if there is a or you can say there is a two words are going to be stored, it means two words means what? 16 to 2, 32 bits will be stored here. So if two words are stored in the first block, so that the second block already stored in the two words. Fine. Now imagine if this particular memory has been filled, only 4 blocks are there, and this complete memory has been full. And next, I want to access any other data which is already existing. Now, how can I go to access? Because that particular data is already in the memory, you can access that. Now, at that particular file, I am going to update and then store in this particular file. Now, I don't have a space in this particular memory. I don't have a space. So imagine there is a virtual memory. Fine. Virtual memory having a larger size as compared to the main memory. Again, there are so many blocks are there. And in this particular blocks, again the fixed size of blocks. If the main memory is stored in this word, 2 words, so definitely in this particular virtual memory page size will be 2 words. And in the virtual memory, you can see here, these are called as a pages. And in the main memory, it is called as a blocks. Fine. And these particular identification of block here, it is called physical address. And the virtual memory, these identification of the page number is called as a virtual addresses. Fine. Now, these size will be same, but the size of the virtual memory is larger as compared to the main memory. Fine. Suppose that the main memory, all these values have been filled. So, I needed any particular technique so that I can remove these pages, these particular information to another. So that this particular space will be vacant. This space will be vacant, so I can store some other value. So that's why it is called as a replacement algorithm. This particular page will be stored in the next particular main memory and then stored. It means what? So you can say page replacement algorithms are used to manage how pages are swapped in and swapped out. Swapped in means if that particular page is stored here, that is called swapped in, and if the virtual memory page is going to the main memory, then it is called as a swapped out. So they are crucial for the virtual memory management in the operating system. So here how you are going to replace these particular page replacement algorithm. We process to need some page not in the memory or the one more word is there, that is a page fault. Page fault, what is the meaning of page fault? If the particular page is not found in that particular memory, then it is called as a page fault. Suppose you have a main memory here and the virtual memory here. Fine. This is your virtual memory and this is your main memory. As you see that the main memory, this is the permanent location. All the data and information are stored in the main memory. In the virtual memory is nothing but it is the illusion that actually there is a memory existed for the users, but actually it is not. It is just as an illusion, and the virtual memory size is the how you are going to calculate the virtual memory size, that is actually what is the size of the auxiliary memory or a secondary memory stored here, that is in the virtual memory size. Fine. So let's take an example of the size of the virtual memory. If I have a 64 GB pen drive, fine. and external hard disk is 64 external hard disk is there. The totality of this auxiliary memory is the size of the virtual memory. Fine. So, virtual memory is the illusion, but it is the size of the virtual. Fine. Now, when the process is started for the page replacement algorithm is simple. When main memory has been filled and there is no space to store any other data, so that this particular page will be going into the larger memory space, and in this particular memory these particular pages will be going out, and then this particular blocks will be free. That is the page replacement algorithm. Fine. So, page replacement algorithm actually determine which page should be replaced. Maybe possible it is the obsolete pages, or it is the newer one, or a current one you are going to replace. That is, and then after the page fault occurs, and the page replacement, the main motive of the page replacement algorithm is to replace the algorithm with a page fault and minimize the page fault and optimize the performance. So, this decision is made using the page replacement algorithm to minimize the number of page faults and optimize the system performance. Now, these are the three types of algorithm, that is a first in first out, LRU, least recently used, and the optimal page replacement algorithm. In the first in first out page replacement algorithm and least recently used algorithm and the optimal page replacement algorithm, it is the, you can say it is the optimal page replacement is the best case algorithm, and FIFO is the first in first out algorithm. Now, actually what is going on into the page replacement algorithm, there is a hardware mapping is also there, and the memory management software together, they make a virtual memory. And the virtual memory organization is a consolidation of the hardware and software system. Fine. Now, how the FIFO algorithm will be going on. First in, first out. There are actually algorithms is the first in, first out. Actually, what is going on in the first in, first out, you can see here, that is a FIFO algorithm chooses to replace the pages that been has in the memory in the longest time. If it is in the longest time or a highest time, then that particular page is going to be replaced. Otherwise, it will be keep into the memory. And you can see here that is and in the LRU policy is least recently used. Which particular LRU technique is used in the more complex to execute but has been more interesting on the pre-assumptions. When a page is referenced, it is associated counter is set to 0 at permanent intervals of the time, and the counters related to all pages directly, and memories are incremented by 1. Now, let's take an example of the first in, first out algorithm. In the first in, first out algorithm, what are the steps? First, the oldest page in the memory is replaced first. Simple, it is very simple. It does not consider any page uses. So, let's take an example. That is, the simple example is here. Suppose that these are the page frame reference number and the page frame size is 3. Generally, the page frame size is 3. So, you can draw a rectangular box with a 3 page frame size, and the first page reference number is 1. Here we are going to find out the FIFO technique. Fine. FIFO is there. So, first you have to write 1 here, and the next, now the pages, page reference number, there is a vacant blocks are there. So, directly you can write it here 1, 3, and the next one you can write here 1, 3 and 0. This is so simple. After that, I have a 3 number. This 3 is already here, just to write it here as a hint, because that reference number of the page, 3 is the actually page frame reference number, and this 3 is automatically in this particular page sequence number. So, there is a hit. Now, the next is the 5. Now, because this block has been filled, then which particular page page is going to be replaced? Now the technique comes first in, first out. First in, first out means that which particular page which is coming first into the memory, it should be replaced. Now you can see here, out of comparison of 1, 3 and 0, 1 is coming at the starting point and the 3 and the 0. So we can replace this one, 1. And now the 5, 3 and 0. Simple. And the next one, that is a 6. Now again the page reference is already filled. Now which particular value is going to be replaced? 5 is recently come, we cannot replace it here. 3 is there and 0. 3 comes at the 3 times and the 0 comes only 2 times. So you can see here that the 3 is at the highest time residing in this memory. So the 5 is here and 0 is here and 3 is replaced by this 6. Simple. Next is the 3. In the 3 value, there is a 3. Now the 5, 6, 0. Finding out 5 is recently come, 6 is just currently come. The 0 is here, so 0 can be replaced by the 3 value. That is 5, 6 and 3. So you can write as an answer total number of page faults equal to, you have to count out, counting this 1, 2, 3, 4, 5, 6, that is 6. Total number of page faults will be there, that is a page fault 6. Let's take in another example. So this you can see here 1, 3, 0 and you can see the total page fault will be 6. Fine. Now you can take another example of the FIFO, that is like suppose there is a some 0, 1, 3, 2, 5, 6, 2, 0, 3, 2, 1. Suppose this, and you have to find out the number of page faults by using the first in, first out. First, you have to draw the number of page frames. Here you can see that is by default there is a 3 page frames. So just you have to write. Otherwise, it will be given in your question that the 3 page frames are there. Fine. Now, in this 0, you have to write it here. Next, 0 and 1 will be here. There is a vacant places, so you can write it here directly, 0, 1 and 3. Fine. Now, the 2 comes. 2 is here and this particular 2 is what? When the 2 is written over here, 0 comes first. You can see the tricky part of the first in, first out is this. Which particular page you are going to replace, which is because the page frame size is 3. So, just check it out which particular page comes 3 times. Then the 4th times it is going to be replaced. Here we are going to replace this 5 because the 1, 2, 3. 1 comes 3 times. Here you are going to replace this 3 because 1, 2, 3, 3 values comes here. Next, this value you are going to replace because the 1, 2, 3 page frame size is 3. So, 0, 0, 0. When this value comes 3 times, then you are going to replace this one. So, again the same tricky or a shortcut method you can use in the first in, first out method, that is a 2. So, just finding out 1 comes 2 times, 3 comes 1 times and 0 comes 3 times. So, you can simply write down this 2, 1 and 3 is there. Next is the 5. 5, now you can check it out, 2 recently come, 1, 1, 2, 3. So, 1 definitely replaced by 5, 2 and 3 will be residing like this. Next is the 6. This 6 is there. So, you can finding out 2 times, 5 just recently come and the 3, 1, 2, 3. It can come over here 3 times. So, 3 is replaced by the 6 and 2 and 5 is written over here. Simple. Next is the 2. 2 is already there. So, there is a hit. Next is the 0. So 0, you can see here 2 3 times, 5 2 times, 6 1 time. So 2 1 2 3. 0 is 2 is replaced by the 0 and the 5 and 6 is here. Next the 3 comes. This particular 3, how you are trying to communicate? This 1 2 3 is there. So 5 is replaced by 3 and the 0 and 6 simply you are writing here. Next 2 is there. 2 means 0 comes 2 times, 3 comes recently, 6 1 2 6. So 3 you are writing over here. 6 is replaced by 3 and the 0. 3 is already come, sorry. Next 3 and 6. This 2 is over here. So 2, 3 and this one. 0, 3 and 2. Next is the 1 and the 1 is what? Because 0, 1, 2, 3. 0 comes. So 1, 3 and 2. So your answer will be number of page faults. How many number of page faults will be there? You have to counting this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This number of page faults is 10. You have to count it. Fine. This is the simple first in, first out. Now the least recently used. Least recently used means pages will be replaced which is least recently used. Just least recently. So now what is the technique? It replaces the page that has not been used for the longest period. In the first in, first out, you are replacing that particular page which comes first. But in the least recently used, the particular pages will come which is least recently used or which is not been used for the longest period. And there is a good approximation of the optimal algorithm and it requires the keeping track of the page history. Now, this is just as an example. Again, the page frame size is 3. Okay, the page frame size is 3. Now, again, you have to make a page with the page frame size 3. Page frame size is given. Always it is written in your question. So, now the first 7, simple. Next is the 7 and 0. That is again simple. Next is the 7, 0 and 1. This one. Now the 2 comes. Your page frame is already been filled. Now, the tricky part comes over here, that is least recently used. When you are going to insert this 2, which is going to replace? Going to replace means least recently used. You can see as the backward direction. In the least recently used technique, you have to, whatever you want to replace, the 2 value, 2 is the pointer and go to the backward. 7, 0, 1. 1 recently comes, 0 comes and 7 is the least recently used. So, 7 is going to replaced by 2 value. Now, the next one is the 0. 0 is already there. So, you have to write it here as a 2. Hit. Next is the 3. Now, the 3 is the pointer and which particular value is going to replace. You can see here 3 is there. Now, your pointer comes over here. Your pointer this 3 to this 0. Abhi just it comes 0. Next 2 comes. 1 is the least recently used. So, you have to replace this one by the 3. 2, 0, 3. Fine. And the next one is 0. 0 is already there. So, you have to write just hit. Next is the 4. 4 is there and which particular out of this 203 you are going to replace. How you are going to replace this? This particular 4 is there. Just pointer, set the pointer here and from the backward direction. In the backward direction 0 comes recently. Next 3 comes recently and least recently used is the 2. So you have to replace 2 by 4 and 0 and 3 will be written over here. Next, there is a 2. Now the 2 is the pointer, 4 recently comes, 0 comes, 3 will be replaced by the 2, 0 and 4. Next is the 3. This 3 is there, this particular 3 is what? Now in the 3 value, you can see here, this particular 3 is not in the page frame, so there is no hit. Now from the pointer here, 2 comes here, next 0, so 4 will be replaced by 3, 3, 0 and 4. Next is the 0, 0 is already there. Next is the 3, 3 is already there. Again the hit, and now the 2. 2 have to be replaced. 3 recently come, 0 recently come, 4 you have to write down. So you have to write down 3, 0 and 2. Fine. Now the 3 is already there, there is a hit. So the number of page faults will be number of page faults equal to what? 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be the number of page faults, or you can say this is the answer. Least recently used, you have to remember only one thing. What you have to think, that is in the 701, whatever the value, just to write down simple. After that, check out the pointer and go to the backward direction. If that particular backward direction, that value come over here, it is not feasible in the practice. So you can see here in the, again the same problem is here, but now the optimal solution we can find. Here the page frame size is 3. Fine. And you have to find out the optimal solution. This is the optimal page replacement algorithm. Optimal page replacement algorithm. Now again you have to draw the 3 values. Fine. First you have to write the 7 and the next, and always don't write in the same page frame 701 or all the 3 values at the same time. No, it is incorrect. You have to write first 7, next in the next page you have to write the next pages, page references, and after that you have to write this one. Fine. Now the 2 is there. Now you have to replace the pages, and how you are going to replace the pages, that is the 2 backward direction. But now in the optimal solution you have to draw into the forward direction. Now the first thing 2 is there. Which one is going to replace? In the forward direction you have to find out 0 recently come, next 3 or the 1. 1 didn't come and the 7 didn't come. Now you have to take the decision, because the 7 didn't come in the future and the 1 is also not come. Fine. So either you can replace it by the 7 and or you can replace by the 1. Both are the correct. Fine. So I am replacing it here with a 7. Now the 2, 0 and 1 is there. You can also replace it by the 1 also. Fine. Next is the 0. 0 is already there. Now the 3. 3 is there, and which particular value should be going to replace? Now you can see here, that is 0. 2 it will come, 0 recently it will, in the future it will become, but the 1 didn't come. So you can replace by 3 as the 1, 0 and 2. Only you have to remember that in the LRU you go to the previous side, or you can say the backward side, and in the optimal you have to take the optimal prediction of the page frame, that this particular page frame can be used in the site. Now in the 203, now the 4 will be there. This particular 4, which particular value is going to be replaced? 2. It recently come. Next the 3 will come, 0 will be come lastly as compared to the 203. So 0 will be replaced by 4 and the 2 and 3 will be here. Now again the 2. 2 is already there, so you have to write 3 is already there. You have to write hit. You are not going to make the page frame when the hit will be there. Simply you have to write down. Now the 0 is there. This particular 0, this 0 means what? Now which particular value is going to be replaced? 0 is there, means what? The 2. You can see 2 is here, 3 is there, 4 didn't come. So this 0 will be replaced by the 4. 0, 2 and 3. Fine. Next, you can find 3. 3 is already there. 2 is already there. And the next 3, that is also there. So the number of page fault for this is 1, 2, 3, 4, 5, 6, 7. So you can see for the same number of pages, the optimal solution is always lesser number of page faults. The same procedure, same page numbers was there in the LRU technique, but we are getting the total page faults in the this. You can see here, we can page faults 9. But now here, you can get the page number as a 7. So in the optimal page faults, you can see here, always there is a number of page faults will be lesser. Fine. Thank you.